Hi friends, welcome to my YouTube channel. In this video, we will discuss about what is Kubernetes and its component. Let's start with what is Kubernetes. Kubernetes is often abbreviated as K8S. It is just the first and last letter, and in between we have 8 letters. So it is named as K8S. It is a container orchestration tool. It means it is helping for us to maintain a clusters where we want to handle multiple containers. And with the help of Kubernetes, we can automate our application deployment. We can scale the application, and also we can manage our applications with ease. It has features such as auto scaling, auto healing or self healing, and service discovery. We can deep dive into these features in our later videos. Kubernetes initially was built by Google, and now currently it is being maintained by Cloud Native Computing Foundation. Let's jump to Kubernetes components. It has control plane, or also known as master node, data plane, or also known as worker node. Control plane has several components such as etcd, cloud controller manager, API server, scheduler, controller manager. And for data plane, it has components like kubelet, container runtime, kubeproxy. We will discuss each of these components now, starting with etcd. Etcd, it just act as a database, and it stores the data in the form of key value pair. It contains information of how many nodes are there in the cluster, how many pods, and information regarding secrets, configs, and there are some concepts called roles, service accounts, and role bindings in Kubernetes, which we will discuss in the later videos. So these all informations are stored in etcd. Basically, whatever we get an output when we execute kubectl command, so that output is being fetched from etcd database, and etcd is only accessible from API server for the security reason. Let's jump to Kube-apiserver. Kube-apiserver, it is the primary management component of Kubernetes clusters, and which is responsible for all the orchestration operations within the clusters. It has few steps, such as when we want to create a pod, first Kube-apiserver, it gets this command with the kubelet kubectl. When we run the command line interface kubectl command, so it get that command, and then the first step what API server is do is it authenticate the user, and then it validate the request, then it retrieves the data, and then it updates the etcd, and with the help of scheduler and kubelet, it launches the pod on a specific node. Like Kube-apiserver, it instruct the scheduler, okay, we want to create a pod, and scheduler what will do, it will see like, okay, we have a pod which is not assigned to any of the node, and scheduler task is to make sure like it will assign some node, so that the pod is being launched in that node. So it will just tell that information to Kube-apiserver, and Kube-apiserver instruct kubelet to launch the pod on that specific node to the kubelet. That is the function of API server. Let's jump to scheduler. As I told, scheduler, it decides which pod should go on which node, but it does not place the pod in node. That is the responsibility of kubelet, and it has steps like, first it will filter the nodes, it will rank the nodes, and after creating the pods, it will check how much free resources is left on that node. For example, we have 3 nodes of, like, no, first node is of 4 CPU, second node is of 8 CPU, and third node is of 16 CPU, and you want to launch a container having the resources like 10 CPU. In that case, node 1 and node 2, which are like less than 10 CPU, those are like 4 CPU and 8 CPU, those are filtered out, and then it will rank. Okay, the third node is feasible for me to launch my container, so it launches the container and the pod inside that, and then calculate the free resources in that nodes, and that it will give back to the Kube API server. Kube API server redirect that information to etcd, and it updates the etcd. Now moving to the next component, that is Kube-controller-manager. Kube-controller-manager, it is a process that runs continuously, which monitors the state of various components within the cluster or system and work towards bringing to the desired state. Suppose there is some config change in your cluster, or there is change in the image on the container which we want to deploy it. So container will spot that change, and it will start working towards the desired state. It will see that the actual state is different from the desired states, then it start working for getting the desired state. It has different types of controllers, such as node controllers, replication controllers, and lot of other controllers. Even we can create the custom controllers in Kube-controller-manager. The node controller is like, if the particular node is not reachable or anything, it will destroy that particular node and it will launch a new node. So the node controller responsibility is launching a new controller, replacing that destroyed controller. And for replication controller, there we have a concept of replicas in the pods. So it always monitors the desired state of the pods. Suppose on one of the container we want to maintain a 2 pods, so in that case the replication controller will maintain that desired state. Moving to the next, Cloud-controller-manager. Cloud-controller-manager, this component will come into picture only when we are handling with cloud providers. When the Kubernetes cluster is on the on-prem, or for learning purpose you have installed the Kubernetes on your PC, that time Cloud Controller Manager component will not come to the picture. Cloud Controller Manager only is used with the service provider. For example, when we use AWS, Microsoft Azure, or GCP, that time Cloud Controller Managers are being used. They interact with the cloud platform from the component which we have in our Kubernetes clusters, and then it will launch. For example, if you want to use EKS service in AWS, or if you want to use AKS service in Microsoft Azure, that time Cloud Controller Manager component is used. Kubelet, this is the component of worker node. This act as an agent and which runs on every node in the cluster. Its steps are: it first registers the node, it creates the pod, and it monitors both node and pod with the help of API server. As I told, API server is the primary component for all the orchestration operations happening in the cluster. So it interact with Kube API server, it get the instructions from the Kube API server, and it gives all the details to the Kube API server, such as registering nodes in the cluster, creating a pods on the clusters, and monitoring these pods and nodes. QProxy. This, like, no, we have a concept of service in the Kubernetes. So when we deep dive on the service in Kubernetes topic, that time it will be more simpler to understand QProxy. But as of now, you just keep in mind QProxy is used to update a rules, or like, create a rules for routing traffic to pods which are behind the service. Service is used to expose our pods traffic which is like no, might be it is a web server or anything we are running on the pod, and if we want to expose it to the outside world, that time we create a service in Kubernetes. So that time when we have a new service, it detects that service changes in the service or the endpoints, like if there is any change in the port number or anything. So those are the endpoints. So when it see those changes, it has several modes, like in the second point I mentioned, IP tables, IPVS, user space and kernel space, these modes. So it uses those modes and it updates the routing traffic to the pods behind the services. But yeah, we will deep dive into this concept when we learn about services in Kubernetes. Next component is the container runtime. As for Java, we have Java runtime. Similarly, for containers, we should have container runtime. And container runtime interacts through container runtime interface, which defines API for creating, starting, stopping and deleting containers, and also for managing images, containers, networks, etc. Hope these all are clear. If you have any doubt, please comment to this video so that I can come back and answer your queries. Thanks for watching, friends.